you can find a PowerPoint presentation in the repo under the folder fMRI Singularity tutorial, Singularity commands. Okay, and you can download that, save it, because if not, you cannot open it correctly. And those would be the commands we will use for the tutorial, so you don't have to open the edit or whatever, and it's all fluent. Okay. I'm gonna actually download my tutorial, my presentation, and we can start. So before we start, I'm gonna ask a few questions. So, are you related to the word containers? You already know a bit how this goes? Okay, that's good, because we're gonna talk all about this. I mean, I'm gonna make this easy for the ones that haven't heard anything about. So, and I'm gonna relate this all to reproducible neuroscience, because what we all want is that something that we have done in our study, well, first of all, is reproducible, which is what we are going to talk about right now, which is that with the same data and the same code, you get the same results. This is the first step in any kind of generalization. And then you can try if with a different code you get the same, and you can say your result is robust because different analyses have pointed to the same direction. Or you can say that with different data and the same method, you can replicate this. And finally, if you can do all of this, you can say that this is general support. Oh, sorry. But the thing is that let's go to the first part, which is the part that we are interested here about, because let's go to something that we all already know: cooking. So if you are cooking and you want to make a recipe and share it with the world, you just need to put a list of ingredients, the recipe you are going to follow. No, you use some cookware, and with that you produce the meal, which is wonderful. Okay? And imagine somebody in another part of the world wants to make this wonderful paella, but they don't have a lot of idea, and they add some ingredients that don't really matter. They change a bit the recipe, they do different cookware, and what do we got? Something that might be nice, but it's not really a paella. Or something that is really awful. And it's nothing that you wanna eat or whatever. So of course, I'm not talking about cooking. I'm talking about how to do a reproducible workflow. Okay? And even, I mean, this first slide is not necessarily about reproducibility, but it's like a few things that you should do if you wanna do a reproducible study. And the first of all is that maybe not pre-register, but define the study correctly. Okay, how many subjects are you going to acquire, the data, the type of data you are going to acquire, the steps you are going to take. Okay, that would be the first thing you should do if you want to do properly a study. Then, when writing your code, comment it, because you are going to share it, and this is basic. Like, if you don't comment your code, somebody's going to look at it and going to be like, and it's going to take forever to understand what you did in there, okay? And also, control it with Git as Eneco teach you, because if not, if you make some kind of mistake, it's going to be horrible. It's going to be terrible, okay? And maybe a lot of people is going to jump over me about what I'm going to say, but avoid private software at all, unless it's completely necessary, okay? Because if someone cannot reproduce this, it's going to be even more difficult to reproduce. It's going to make it difficult to try to reproduce your study. So this would seem like a really nice way of doing a reproducible workflow. Okay, like you have your data, you have the finding, you have your your recipe, sorry, that's a mistake. And then what you do, you use a cluster or a personal computer that has everything installed, no? But there is a problem here. What is not reproducible from this schema? Can you tell me? No, the data and the code, if you share it, is reproducible, no? But you cannot reproduce a cluster or a personal computer. And this is actually a problem, because there are some studies that have dedicated to see this. And for example, in this one, where they did a free surface analysis, they found out that if you use two different clusters, okay, with the same free surface building, I mean, you can go through the spec, it's mostly all the same, but the difference is one is a CentOS, the other one is a Fedora. And then you find out that there is differences in between measurements, and that there is and they are significant. So it's very important where are you making your results. And it even happens between versions of the same software, okay? Like this is p-values, okay? So this is the 0.0001 p-value. So you can see there are very huge difference between different versions of free surface in the same computer, okay?
But what is the cause there? Something modified in the
maybe a bug or something that was modified, or I mean, you cannot really say. I mean, and I didn't really. But the thing is that there is a way to solve this, and there is a way to avoid this kind of problems, and that's basically defining your execution environment, okay? And that can be done with a container. That can be done here. So the thing is, what's a container? A container is what do you call it? A file where you have your own operating system that has all the libraries, all the software installed, everything specified, and that you can use to run your experiment in any place, okay? Like you can basically work in any kind of computer. And I know that maybe a lot of you are related to Docker, but I'm not gonna use Docker for one main reason, because right now there is a tendency of working in clusters, and Docker is not good in clusters. Like if you go to a cluster and say, hey, start me Docker, they're gonna go like, that doesn't work here. So that's why I choose to teach you Singularity, which is a very similar program to Docker, actually compatible with it, that you can use to create your own containers, install your own programs, and control that environment, and therefore be able to share it and that other people reproduce your results. So we're gonna go through the little tutorial I prepared to make you a bit familiar with the command of Singularity. So I'm gonna close this now. Gonna open Singularity commands in here so you can see them. I'm gonna put one here and this here. Can you see the other one? There's the black screen, or sure? Okay. So first of all, let's be familiar with the command Singularity. Well, no, first of all, sorry, let's copy from materials fMRI Singularity tutorial. Okay. Remember to do the -r, sorry. -r. And then go to, then put it into date, okay. Just like that. So you would go to CD data Singularity tutorial. Okay, now we're ready. Let's start with the command. So this command is the main command of Singularity. You can do everything with it. You can pull images from online, build your own images, execute commands from inside a container, run a container, because a container can be actually run sometimes if they configure it properly. You can basically do whatever you want with it if you know how to use it. So let's start with a simple example. So we can pull a public image from the network. You just put the library you wanna get it from. You can choose Docker or actually the Singularity library, whatever you want. It's completely compatible. Okay, it's gonna store the image and it's gonna create a file with it. Okay, you can actually inspect it. Just a second. Might take a bit. Yeah. You can actually inspect it and say, well, this image was gotten from the library code.loco with this version of Singularity. It's just like a minimum information of how the image arrived there. Okay, it's not really descriptive, but it's something you can start with. Another thing you can do is build images from like download the image and storage. And I don't know why, but they changed the version of Singularity, and right now pulling and building public images does the same. Like they take it from the internet and store it into a file in your directory. I don't know why they changed it, but before with pulling you only store the image in memory, and now for some reason you also drop it. But the interesting thing is that if we download an image, we can interact with it. We can, for example, we can use different commands inside the, so if I put code, say mu in my terminal, nothing happens because there is no program in it. But if I access the container, no, locus if latest, sorry. Yeah. So there you go. You can interact with the image. You can make it run commands. For example, this silly command that shows you a cow that you can and you can modify what it says, or you can actually take it directly from the library. This time without saving it, and then come on. Okay, sure. Yeah, no. What's the problem here? There's no problem. Why would it be a problem? No. And then, well, anyway, you can try it. I don't know why it's not working, that one, but whatever. But the thing is that libraries containers sometimes are already applications. Like for example, when you did the tutorial the first days with Stefano, you run a Singularity command there in that moment, and you say Singularity run. That is telling the container to run the script that the main developer told him to. Like for example, in this case, you can choose copy this. It will download the image, which takes a bit. And instead of showing the code, you have a nice code with a lot of colors. Okay? I mean, this is a silly example, I know, but I wanted to make this easy, to make this. You will need your charger. Why? Oh, sure. That's why. Thank you. There you go. Okay, as I was saying, The important thing is that you can interact with the image, and you can do anything within that you want. But imagine you don't want a public image, that you need something really specific, something that is not in the internet for some reason, that nobody created. That can happen. It happened to me, and it was hard to solve it, but I managed. So you can actually modify a container from a public image and install whatever you want, okay? And that you can do with two different methods. You can first create a Singularity sandbox, which is basically, instead of creating a file, creating a directory that you can modify. Okay, you choose copy this command that downloads against a public library, and then you just have to say, okay, now that I have my file, I want to modify, so I need to have permissions. Okay, this is like writing in Ubuntu that I want to install things. Okay, let's wait for a second. Come on. There you go. So you can actually say sudo Singularity Singularity shell minus readable. Very important, because that's what makes you able to write things in it. And then you say Bionic. Okay? And it's gonna ask you for the password of the virtual machine, which I hope more or less you remember. Well, no, that you remember. And you are just inside the Singularity container in a shell. Like, this is like you suddenly logging into a cluster. This is the same, like you logging into the Singularity container. And now, as you can see, there is no Python. So we could install Python. We could say apt get install Python 3. Epa, no, sorry. Apt update, very important. Okay, this is essential. If not, you are not gonna be able to apt-get is not gonna be able to see the libraries. And now you can install Python, because Python is everywhere. You just say yes, and you have Python. Okay, it's gonna take not too much. Yeah.
Is there an automated way for the Singularity to basically scrape your operating system parameters, so you don't need to install everything from scratch in the container? You just say, this is my system, this is what it
No.
has. You have to
No.
manually do it.
You have to download a public image and then start building from scratch. I know it's a bit crappy in that sense, but
You already might have everything on your computer.
but you cannot. I mean, it's not that easy. That, you know, like your computer is not a container. So
there's no way of
no, you cannot do that. You have to. I know it's a bit crappy, but you have to start from scratch. Okay, I know. I have to do myself this, and with installing FreeSurfer, and it's it's very difficult. I know. That's why I wanted to start from the beginning, because now we are gonna see a file on how to install AFNI. Like, we are not gonna execute it. I'm just gonna show you to see that is difficult. But this is something that is important. That this is a tendency. This is something that is being done by a lot of people, and that is, I think, is the right way to do things, so we can reproduce and share of results correctly. In any case, I mean, sorry that I cannot give you a better answer, but we cannot.
and then it would not interact with anything with you already installed on your computer. You will just always working within the Docker, within the container.
Exactly.
And it will never have a compatibility issue saying, no, in this version, this file dot something matters called this, or dot pu is called this. So it will not see anything
No, actually, it's not gonna see anything that your computer has. That's the thing. That is a separate environment. That's the nightmare and also what you want in a sense. So is what we can get. In any case,
So
tell me.
Is there a public image that has nothing? Just
Yeah. Like for example, I choose call here Docker Neurodebian Bionic non-free. So that's a scratch version of like nothing. There is nothing in here. Like there is not even Python 3. Usually Ubuntu has Python 3. Like this is something that doesn't have anything. But you can actually build from images that are already modified. Like there is an image from Acne, there is an image probably for FSL, for fMRI prep, so you don't have to start from scratch. The only thing that is better about starting from scratch is that you actually know all the things that there are there. And I'm gonna get to that point in a moment. Actually, right now, because I was gonna show you the other way of creating a Singularity image, which is basically making a script that instead of it's like instead of making your code in the terminal, making your code in a script and then give it to the program and it will do it for you. It will run it and then create the image. So this is actually something nicer because it gives. No se ve muy bien. I'm gonna try to enable editing and no, I'm gonna try to make or zoom in. Yeah. Why is okay? I'm gonna put like here. Okay, yeah, sure. Okay, so this would be a tiny example, and I say tiny because this is probably a bit useless, of how to write what we call a Singularity recipe. That you feed this to Singularity, and you can create your own image. So basically, what you do, you start from a public image. So you say bootstrap, which is basically saying what library do I want to get the image from. In this case, Docker, which is fully compatible, and you say from Ubuntu latest, for example. Okay, you can choose Ubuntu, Neurodebian, CentOS, whatever you prefer. Next thing you do is like you were in a terminal. You start putting what you wanna do, what you want to install inside the machine. Okay, you choose, for example, in this case, you can say update apt-get install Python 3. Then you can put some labels like what's the container doing, who is the maintainer. You can actually put files inside from your computer. You can do that. You can put a script, or you can even copy a directory if that serves you. For example, in here I'm copying a hello world.py that is in this directory. And then you can declare environment variables that will be always inside the container. And finally, as I told you, you can tell the container which command run when you call it with Singularity run. So I actually put this file in the repo, and it's called simple recipe. So you can say sudo, because you need permissions, Singularity build. The name of how do you wanna name your container, and then the recipe that you are using, which is in this case simple recipe. And after putting the password, so of course you can start building, and it's just gonna do it automatically. It's gonna download the image, it's gonna install Python, it's gonna do everything. And if everything and this is the problem, every command has to be correct. If there is a mistake, the program will stop and you will have to re-execute it. That's the only problem. unless you are working with a sandbox, because you can actually create a sandbox instead of directly a container file. You can actually create a directory like before, and then if something fails, they will put the directory in your in where you were working, and you can modify it from there if you want.
Which option is better? I guess the recipe is more reproducible, I guess.
Depends. I wouldn't. This is something that is actually an open question, because in one side the recipe is telling other users what is happening inside the container, okay? And actually, when the container gets created with this kind of method, you actually can see a file inside of it that has the recipe. So you don't even need, if you share the computer, you don't even need to share the recipe because it's inside. But if you don't define your libraries with the exact version and the exact blah, 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 the recipe is going to produce a different container every time. So that's why I say it's an open question, because if you share a recipe, a person that executes in 2016 is not going to get the same that executes in 2018, because there was a change in this library and automatically apt-get downloads the newest one. Okay, so maybe recipes are more traceable, which is actually nice, but if you plan to, I mean, the best thing, what I would do is that always share the container, because the container, because you close it and don't modify it, and that's gonna stay stable. If you share the recipe, you risk that you didn't specify a specific library version, or maybe that, I mean, we're downloading from the internet, so maybe one of the libraries is not standard anymore, is in development or whatever. Can happen a lot of things. We don't control what really happens with the internet, so it may modify a bit the container, okay? It had actually happened to me that I had to modify a script because they changed a library and it wasn't in apt-get anymore for some reason, because they considered that it was deprecated, and I was actually for the APNI container. So now I don't want you to be scared, okay? I want you to use Singularity, and I think it's the best way to do your experiment if you control it properly. But I want to show you a file with an actual recipe of AVNI. I'm pretty sure a few of you know the program, okay? And just for you to know, the file is 126 lines, which is not too much, but to debug it, it takes a while. And basically, you can. I mean, it's mostly the same. So you call I mean, it's the same. You call your operating system that you wanna download, and then you start doing things. You start putting libraries that you need. Yeah, and finally, you install AVNI, and you just try it. We are not going to execute this one right now because it will take a while, but you actually have this you can actually have this in the repo, and you can execute it yourself, and you can try, and you will see that if you have AVNI in your computer, it will be a different version probably, because this will download the latest one in this case. Any more questions? Since
How
you
big
wanna.
is the container?
In this case?
Well, in any case, because
No, it depends on what you are.
No, like imagine that you are going, because I guess the good thing is to start doing your analysis with the container created somehow, no?
Yeah, of course, you want to.
I mean, start at the beginning, and for every experiment to create their own container. So how big are the containers?
Okay, so for example, these AVNI containers, I think is 1.7 gigabytes, and it has AVNI inside. So, But for example, free surfer can be 5 gigabytes. It depends on what you are installing. But the thing is that you don't have to create a container for every experiment. If you are using
If you are using the same container.
like if you are using the same software, or you can use that one, or you need even more, you can get the container, transform it into a sandbox, okay, because you can do that. You can, for example, I have simple SMMG. I can say sudo singularity build minus sandbox, yeah. And then simple sim, and instead of using a recipe, wait, yeah, sorry. Sorry. So you can get the directory, so you can transform it into a directory and start installing whatever you need interactively. So you don't always need to use the definition file, and that's why I told you that there is no better way. There is 2 ways, and you can use both. I mean, you can use one, you can use both, you can do whatever you want. The important thing is that in the end, you create the container file, and you use that for your experiment, and when you are finished, you share it. And any other question? I don't know, like doubts that you might have. Very important thing. Legally speaking, you cannot install, you cannot install private software inside Singularity containers and then share them. Okay, no MATLAB, no whatever. Like, that's why in my presentation I say, like, don't use MATLAB because if you wanna be reproducible, because you can, unless you have unlimited licenses of MATLAB, which I don't think you have because you are not MATLAB owners.
What about runtime?
Yeah, you can use runtime. Yeah, but then you can only use the tools that use runtime, and it's not the same. But yeah, runtime you can use it for sure. I mean, free surfer uses runtime. You can download it, put it in the container, and go for it. But no, you cannot use private software that is not license free. Okay, very important. I'm sorry if you are a bit how do you say, disappointed, but it's what you can do. Any other questions? No? Okay, I hope I haven't scared you. I hope you start using more Singularity. If you have any questions, I gotta leave because I have a doctor in half an hour. And so you have my email, or you have the organization email. You can ask for me. You can try to ask any question. I don't know everything, of course, and I mean, you will have to go to the internet for sure. There is repos, there is a Stack Overflow. Ask. There is a lot of people there waiting for you to ask your question, and they will be answered eventually. I mean, not in the moment, but eventually. Thank you very much to every of you.